Hello, welcome back to the Henstitute. This one's kind of another neat one. So we're going off of the Millikan experiment. So the Millikan experiment had these two charged plates. One of them was positive. Usually the top plate is positive. And then another plate that's negative. And the idea is there'd be an electric field being produced between these. And so when I fired a droplet in here, whatever this little droplet is, the idea is it's going to feel two forces. We are assuming this is negatively charged, so it's going to feel an attraction, an electrostatic attraction for the positive plate, and then we have the force of gravity pulling it down. So this is what we played around with our Millikan simulation. What we want to figure out is what voltage is needed to balance this drop. So we have some information in here. Well, if the electrostatic force is equal to the force of gravity, one of the things we kind of played around with is the electrostatic force would be equal to the electric field multiplied by your charge, and then this would be equal to mass times gravity. Well, the charge is something that we know, but we don't actually have the electric field. We, notice we have just information up here, and we know that they're separated by that much. So one of the things that was pointed out when we did this lab is you connect these two plates up to some voltage, and the distance between the plates and the voltage are going to affect it. So what we do is the electric field, we know it's force over charge, which is why the electric field times the charge should also give you your force, but we can also tweak it, and it can be found by taking the voltage difference across the plates divided by the distance between the plates. And then we multiply that by Q, that equals mass times gravity. So we have the mass of the drop, that's not a problem. We know the plate separation, we just got to change it from millimeters into just plain meters. And we know that the drop has 8 excess electrons, and we know the charge of that. We've got the charge, we've got the distance, we've got the mass, and we know what gravity is. So we just have to rearrange this to solve for voltage. Voltage, if I multiply by the D, that would be the mass times gravity times the plate separation divided by my charge. And I just plug all those lovely numbers in. So my plate separation, D, I know is 3.14 millimeters. I just tack on a 10 to the minus 3 meters here. And then my charge, which is the charge of the drop, it actually might be better to write this as a lowercase q because it's kind of like a test charge in there, but I'm not going to worry about it right now, is 8 electrons. So 8 times this 1.6 times 10 to the negative 19 coulombs. And then I can put in the mass, which is already in the right units, and we're good. So this was just a little help on this. We didn't actually solve for voltage, we solved for charge, but we had kind of the same idea, and we calculated that electric field the same way. Hope this helps with this Millikan problem.